Hello. Today we're going to discuss a problem that shows sometimes you're not able to switch the order of the unions and the intersections. So here we have two sets. On the left side is the union of intersections, and the right side is the intersections of the unions. And we're going to show that they are actually not the same. These two sets are a little bit complicated. You have a index n, m, k, three variables. Here, capital N is the natural numbers, the set of natural numbers starting from 1. All right, so let's look at the left side. One way of studying it is you fix the first index n, so fix n. I'll say some random number, 100. And then we discuss this set. It's the intersection of infinitely many sets where n is, say, 100. So you have an intersection m from 1 to infinity. And you have a k, is an integer natural number. And you have m times k less than, let's say, 100. Now you can look at m. So what if m equals 1? Then you simply have k less than 100. And you have natural numbers, right? So 1 from 1 to 99. 1, 2 to 99. And what if m equals, so this m equals 1. What if m equals 2? And then you have a 2k less than 100. That will make the set to be 1, 2, and 49. Okay, so now you see actually these sets, when m increases, they decrease. So the intersection would be farther away. So let's look at m large. For example, where m equals 100, maybe 100, that's okay. And then you have a set that is 100 times k is integer, is a natural number, right? Less than 100. It doesn't work. There's no k, no natural number would make this inequality work. So this set is actually empty set. So now we see when m is bigger than 100, greater than equal to 100, these sets would be just empty. All right. So for every n, you can show that this set, it's the infinite intersection of sets. It becomes an empty set. Then you have a union of empty set. That's just empty. So the left side is an empty set. All right, so that's empty. Now let's look at the right side. We do the similar thing. Let's fix m. Okay, so m equals, let's choose 1, maybe simpler. And then we discuss this set, all right, the union n from 1 to infinity. And you have a k natural number, m equals 1, right? So k less than n. All right, so when n equals 1, the set is empty. When n equals 2, that set equals just 1. So when n equals 1, we have empty set. When n equals 2, natural number less than 2, that's 1. When n equals 3, and you have a 1, 2. Okay, and you see these sets are actually increasing. All right, it's a union. The union will be the largest set, but let's see if there's a larger set. So let's continue. When n is getting bigger, say n equals 100, and then you have this set, the union, okay, will be 1, 2 to 99. So when n is 1000, you're going to get 1 to 999 and so forth. So when n gets bigger and bigger and bigger, you have a bigger and bigger sets, and eventually it will include all the natural numbers. Okay, so this set includes all the natural numbers. Why? Well, given any natural number, say 1 billion. All right, so you have a 1 billion. You can choose n to be, let's see, to be bigger than some number, say 2 billion. And okay, actually it depends on m. So let's say m equals 1, right? M equals 1, then you choose n to be 2 billion, then obviously this set includes 1 billion. Okay, k less than m, right? K less than n. So you choose n to be 2 billion, then k could be 1 billion. It's included in that set. So any the natural number will be included in this set when m equals 1. And when m equals 2, similarly, you have 2 times k less than n. But when n gets bigger and bigger, this set, the union, so this set would be bigger and bigger. All right. And then eventually it will include all the natural numbers. So what we said here is that for every fixed m, this set is simply the set of natural numbers. So the intersection of all natural numbers would be just natural numbers. So we conclude that this one is all natural numbers. It's a set of all natural numbers, and this set is empty. So they're not equal.